Valentine's Day in 1990, one of the most famous photographs of all time was taken, the pale blue dot. It was snapped by the Voyager 1 space probe on its way out of the solar system, from some 3.7 billion miles away. It isn't much to look at, and the significance of it could easily be missed. But what this seemingly blank image actually shows is Earth as a tiny bluish speck against the vast expanse of space. It's what our planet looks like set against the rest of the cosmos, and we generally take this pale blue color for granted. We know that around 71% of the surface of our world is covered by ocean, and we know that from far enough away, all of that water merges into a deep blue hue. We also know that the gases in our atmosphere serve to shape and refract the light around the planet, thereby dictating how it appears from a distance. But by now, we're used to seeing visuals from the International Space Station as well, as it races around the Earth, providing a God's eye view of what, for all human beings, is home. So we're very aware that so much of Earth, when viewed from above, also appears to be green, thanks to our lush forests, fields, and woodlands. The green color comes from chlorophyll, a pigment in most plants and trees. It's vital for photosynthesis and providing plants with the energy they need to grow and function. Therefore, it's a crucial piece of chemistry in how life on Earth works in general, ensuring that oxygen and carbon dioxide levels remain relatively stable. Importantly for today's question though, chlorophyll also absorbs red and blue light while reflecting green light, which is why leaves and vegetation are predominantly the color they are, green. But what happens if we substitute chlorophyll for something else? Well, according to one theory, that might have been exactly what was going on during Earth's earliest years. The purple Earth hypothesis was first put forward by the renowned biochemist Shiladitya Dasarma in a feature in American Scientist in 2007. And today, it increasingly shapes what we imagine Earth in ancient times to have looked like. Dasarma and his team conducted extensive studies on haloarchaea, a microscopic single-celled archaea found in highly salty environments. These microbes are what's known as retinal-based rather than chlorophyll-based, which means that they photosynthesize light energy from the sun differently. Rather than reflecting green and yellow light as most plants on Earth today do, they absorb it. Instead, they reflect reds and blues, which gives them a purple color when we look at them. Under the microscope, they're said to have a purple membrane, and in some ways they could be described as our more commonplace green cells, but as they might appear in negative. Haloarchaea aren't exactly prominent in the world today. If they were, then every time you walked through the park or cycled through the forest, you'd be met with a sea of purple. Instead, they're typically found in extreme environments only. But the theory is that there may have been a time when retinal-based cells in general were more widespread, particularly when there was less oxygen on Earth, period. So that the entire planet, by our standards, was extreme. To put it into context, the retinal pigment is described as a far simpler molecule compared to chlorophyll, leading to the suggestion that it dominated Earth in the days before what scientists refer to as the Great Oxygenation Event. The Great Oxygenation Event has also been known as the Oxygen Crisis and the Oxygen Revolution. It occurred on this planet between roughly 2.3 and 1.9 billion years ago, transforming Earth's atmosphere from one where oxygen was scarce into one where, as today, it's abundant. Currently, little is definitely known about what the Earth was like just after it was formed, nor during its first billion years or so. But we can chart chloroplasts, i.e. structures within cells that conduct photosynthesis via chlorophyll, to around 3.5 billion years ago. The broad idea is that by the time of the Great Oxygenation Event, chlorophyll-based microbes had become dominant and Earth turned green. Before then, though, it was all about retinal-based microbes, and so the Earth was purple. These could survive in anaerobic conditions without oxygen, and thanks in part to their simpler structure, they were incredibly efficient during the first half of Earth's life, up until chlorophyll took over. The theory is still very much up for debate, but in the meantime, it provides us with an all-new strategy when looking for signs of life not on Earth. When looking at alien planets and star systems, we so often assume that they would ideally have properties similar to our own world's as it is now. The conditions for liquid water and the promise of oxygen in the atmosphere are two key points of interest, for example. And if we were to ever get close enough to look at a far-off world and it was green all over, then the scientists and astrobiologists amongst us would certainly get excited because of the suggestion of life that would hold. But now we're keeping our eyes peeled for purple as well, because we know that if the purple Earth hypothesis rings true, then a planet boasting reddish-bluish shades could perhaps be considered a precursor for life as we know it, a first stage toward life eventually thriving. And so, according to some, purpleness should be considered a biosignature of sorts whenever we're searching the skies for an extraterrestrial presence. One fun coincidence is that the color purple has infiltrated recent pop culture ideas on what aliens would look like. For years during the mid-20th century, the little green man had been the go-to image for anyone penning or filming science fiction. Nowadays, that motif isn't quite so all-encompassing, and aliens in books and films come in a greater variety of shapes and colors. They're no longer always humanoid, and every so often they are purple. Among the most popular are O from the 2015 animated movie Home, Widget from the early 90s cartoon of the same name, and the villainous Ivan Ooze from the 1995 Power Rangers feature film. So perhaps the purple Earth hypothesis has already permeated our collective consciousness. What's clear is that this theory is one which potentially transforms the way in which we look at space and at the history of our own planet. Imagine what the world would look like now if chlorophyll had never taken over from retinal in the way that the purple hypothesis suggests that it has done. For one, Earth may never have oxygenated in the same way, meaning life may never have appeared. But even if life had miraculously emerged under these alternate conditions, the purple equivalents of leaves, trees, and forests, which all could have been totally different multicellular structures in all other ways as well, are a bit of a head trip to think about. In today's world, there are various places you can go to get a small sense of what might have been. All across the world map, there are salt ponds and lakes curiously tinged with purple, thanks to the modern-day retinal-based microbes that still dwell there. Indeed, it was locations like this that first provided Shaladatia Dasarma and his team with grounds to formulate the purple Earth hypothesis to begin with. The somewhat ironic situation is that with photographs of these lakes, it could be argued that there's an almost unnatural element to them. That because of their purple tint, they look as though they don't belong here, or as though these images themselves have been edited for effect, when in reality, the chemical process needed to make stuff purple is potentially one of the oldest known natural features of our planet, older even than the grass being green. A long time ago, everything was purple, and in our ongoing search for alien life, we could be far better off if we specifically looked for purple places of interest. Or at least, that's how this particular theory goes. And that's why it's thought that ancient Earth could truly have been a